Hello everyone, thank you for joining me today. I am Doan Xie. In this session, I will focus on our software solutions. Other sections may cover our hardware platform in more detail, so here, I will focus on the software layer. The main idea is simple. ASRock Industrial software help customers turn industrial PC into secure, manageable, and application-ready edge AI platforms. I will use a simple framework to explain how our software helps across the edge lifecycle. First, we will look at lifecycle operation. Then, we will look at operational protection. Finally, we will look at application enablement. Before we get into the framework, let's first see where our software fits. ASRock Industrial software does not stand alone. It's built on top of our industrial hardware platforms. These platforms provide computing bases for industrial automation, edge AI, and mission-critical applications. But for many customers and partners, hardware is only the starting point. The bigger question is how to use that hardware more efficiently. How do you deploy it faster, manage it remotely, keep it secure and updated, recover it when something goes wrong, and build application on top of it? That is where software becomes important. Our software reduces manual work. It helps partners build stronger solutions, and it helps customers operate edge systems across the full life cycle. So today, please think of software as the value layer that connects our industrial platform to real customer applications. To understand why this software layer matters, let's look at the customer challenge. Edge systems are now used in many environments. You may see them in factory, energy site, retail store, transportation systems, or AI and automation applications. As deployment grows, daily operation becomes more difficult. Manual setup takes too much time. Field service is increasing cost. Software update create risk. System failures may require on-site support, and external devices can introduce new security threats. So the challenge is no longer only computing performance. The real challenge is scale. How do you bring many devices online safely? How do you manage them remotely? How do you keep them updated? And how do you recover them when something goes wrong? And how do you build intelligent applications faster? These are the problems our software is designed to solve. To address these challenges, we look at the edge platform in layers. The ASRock Industrial Edge platform provides the foundation. On top of this foundation, our software adds three major capabilities. The first capability is lifecycle operation. The second capability is operational protection. And the third is application enablement. Let's start with the lifecycle operation. This is about how customer operates each system after deployment. It starts with onboarding. A device must join the customer environment in a secure and a repeatable way. Then it moves into remote management. Customers need to monitor and manage devices across different locations. Over time, software needs updates, and when problems happen, the system needs a recovery path. So the lifecycle operation flow is simple: onboard, manage, update, and recover. Next is operational protection. Here, AiSafeguard helps protect deployed systems during daily operation. It applies Zero Trust control to external devices and I/O access. Finally, we have the application enablement layer. This is where customers create business value through automation, edge AI, and physical AI applications. So the message of this slide is simple. The hardware platform is the foundation. Our software adds lifecycle operation, operational protection, and application enablement capabilities. Now that we have the overall framework, let's look at the software solution inside it. We will start with the lifecycle operation. First, Ai FDO helps onboard devices securely. Then, AiSMA and AiNexus support remote management. Our OTA service helps maintain software after deployment, and the AiOOB supports remote recovery when normal access is not available. After that, we will look at this AiSafeguard for operational protection. Finally, we will move to application enablement with AiUAC, AiUAC Copilot, AI into Agent, and our physical AI capability. Let's begin with the first lifecycle concept, secure onboarding. When you deploy many edge devices, manual setup can quickly become slow and difficult to manage. Each device may need an operating system, application, network settings, and ownership information. You may also want to avoid exposing sensitive credentials at the deployment site. So you need the secure and scalable onboarding process. This is where Ai FDO comes in. Ai FDO is our secure zero-touch onboarding solution. With a traditional approach, an engineer has to configure each device manually. The engineer may need to install the operating system, enter settings, deploy applications, and handle credentials. This may work for a small project, but it becomes slow and costly when you deploy hundreds of thousands of systems. Ai FDO provides a better approach. The device receives a secure identity during manufacturing. When it powers on at the deployment site, it connects to the right service and verifies ownership. It then receives the correct operating system, configuration, and application payload automatically. This removes the need for manual device configuration at the deployment site. It also reduces the risk of human error. For customer and partner, the value is clear. Faster deployment, stronger security, and easier scaling. Once devices are onboarded, the next challenge is daily operation. Different customers manage edge systems in different ways. Some customers already use a standards-based OT environment, such as an all-pass system. They need a standard way to connect edge devices into the ecosystem. This is where AiSMA fits. AiSMA provides a redfish-based management interface for OT integration. Other customers want a ready-to-use portal for daily fleet operation. They need to manage Windows and Linux edge devices from one central place. This is where AiNexus fits. AiNexus provides centralized visibility, remote access, alerts, logs, and operational control. So AiSMA is for standards-based OT integration, while AiNexus is for centralized fleet operation. Let's first look at AiSMA. AiSMA is designed for customers who want to connect edge device management into a standard-based OT ecosystem. It provides a redfish-based management interface on ASRock Industrial Edge platforms. Through this interface, an all-pass system or another OT application can access device information in a consistent way. For example, the system can read hardware status, monitor sensors, receive events, and manage accounts or certificates. The key point is open integration. Instead of building a different management methods for each device, customers can use a standard interface. So AiSMA is a good fit for all-pass and other OT environments that value openness, interoperability, and standardized management. Now let's look at AiNexus. AiNexus is designed for customers who want a ready-to-use platform for daily fleet operation. From one central portal, your team can monitor device status, access system remotely, and review alerts and logs. AiNexus can also collect system data, such as CPU usage, memory status, and storage information. This gives your team a clear view of device health across the fleet. AiNexus also provides REST API and WebSocket interfaces. These interfaces allow third-party systems to exchange data and send commands, such as a remote reboot request. When deeper system access is needed, AiNexus can work with lower-level management technology, such as Intel ANT or AiOOB. So AiNexus is more than a remote access portal. It helps your team monitor distributed devices, respond to issues faster, and manage daily operations from one central place. After daily operation, the next challenge is software maintenance. Edge devices may need bug fixes, security updates, new features, or AI model updates. When systems are deployed across many locations, manual updates become slow and difficult to manage. They can also create version differences across devices at different sites. So we need a safer and more consistent way to maintain software after deployment. This is where our OTA service becomes important. Our OTA service helps us update ASRock Industrial software and the middleware after deployment. The OTA server manages the update package. The client receives the package, installs the update, and reports the results. This makes software maintenance easier across devices at different sites. For supported NVIDIA JSON platforms, we also provide an AB dual slot update design. While the system continues running from slot A, the new version is written to slot B in the background. If the system cannot restart successfully after the update, it can return to the previous version. This helps reduce downtime and makes software updates safer. Even with good management and regular software updates, system failure can still happen. A device may freeze, the operating system may crash, or the BIOS may fail. When this happens, normal remote access tools may no longer work. So customers need another way to reach and recover the system without going on-site. This is where remote recovery becomes important. And this is where AiOOB and AiOOB management comes in. AiOOB provides an out-of-band recovery path. It uses an independent M.2 control module that works separately from the main operating system and the BIOS. So even when the main system is down, AiOOB can still support hardware-level recovery. To make this function easy to use, we also provide AiOOB management. This is the management console for AiOOB. From the console, your team can restart the device remotely, monitor the hardware status, clear CMOS, and recover the BIOS. This gives customers a practical way to manage recovery action from one place. For customers who want deeper integration, AiOOB also provides a Redfish-based interface, but the main idea is simple. AiOOB gives you the recovery capability. AiOOB management gives you the console to control it. Together, they help reduce downtime and avoid unnecessary on-site service. So far, we have covered how to onboard, manage, update, and recover edge systems. Now, let's look at another important area, operational protection. Once a device is deployed, security risks can also come from physical access. For example, someone may collect a non-USB device or another external peripheral. That device may contain malware or try to access sensitive data. So deployed systems need a way to control external devices during daily operation. This is where AiSafeguard comes in. AiSafeguard helps protect deployed systems from external device risks. It uses a Zero Trust approach. That means the system does not automatically trust a device just because it is connected. When someone plugs in a USB device or another peripheral, AiSafeguard checks the device first, then it applies the right policy. A trusted device can connect to a controlled environment. An unknown or risk device can be isolated in a sandbox. The system can also monitor suspicious behavior and send alerts. This helps reduce the risk of malware spreading through physical interfaces. So AI safeguards give customers an extra layer of protection during daily operation, especially in environments where external devices are frequently connected. So far, we have focused on how to operate and protect edge systems. Now, let's move to the application enablement layer. This is where customers build new value on top of the platform. We see three main directions. The first is open automation. AiUAC provides the runtime middleware where AiUAC Copilot helps engineers create IEC 61499 applications faster. The second is Edge AI with AI into Azure. The third is physical AI, including robotics and autonomous machines. Together, these capabilities help customers move beyond device operation and build more intelligent edge solutions. Let's start with AiUAC. AiUAC is our IEC 61499 runtime middleware. It's not the automation application itself. Instead, it provides the execution environment that runs IEC 61499 applications on ASRock Industrial Edge platform. Why does this matter? Traditional industrial control systems often tie software closely to specific hardware. This can make upgrade and future expansion more difficult. IEC 61499 provides a more open and distributed approach. With AiUAC, customers can deploy IEC 61499 applications on our edge devices and reuse the application design across different projects. So the key message is simple. AiUAC is the middleware layer that executes IEC 61499 automation application at the edge. Now, let's look at AiUAC Copilot. AiUAC provides the runtime environment. AiUAC Copilot helps engineers create the IEC 61499 application. The idea is simple. An engineer can describe an automation task in natural language. AiUAC Copilot can then understand the request, ask follow-up questions when needed, and help generate IEC 61499 function blocks and application logic. For example, an engineer may ask the system to create control logic for a stepper motor. If some details are missing, the Copilot can ask for clarification before generating the application. The application can then be deployed to the AiUAC runtime for execution. So the relationship is clear. AiUAC runs the application. AiUAC Copilot helps engineers create it faster. Now, let's move from open automation to edge AI applications. AI into Agent focuses on AI vision inspection and AI agent use cases. For example, a manufacturer may need to inspect product quality on the production line. With Edge AI, the system can analyze images locally and provide results in real time. This helps reduce manual inspection effort and make quality control more consistent. AI into Agent can also use an AI agent to help users understand the results through a natural language interface. So the value is simple. AI into Agent helps customers turn inspection data into useful insight at the edge. Beyond Edge AI vision, we are also building our physical AI capability. Physical AI brings intelligence into robotic and autonomous machines. A robot does not rely on only one AI model. It needs several models to work together. Vision models help the system understand the environment. Speech-to-text helps the robot understand voice commands. A language model helps the system reason about the task. Text-to-speech allows the robot to respond. And the motion control logic turns the decision into action. In more advanced cases, a vision language action model can connect perception, reasoning, and action more directly. Our robotics proof point shows that we understand how to coordinate these AI workloads locally at the edge. This is our physical AI direction, from perception and reasoning to intelligent action. Let me close with the full picture. ASRock Industrial starts from strong industrial hardware. Our software adds the capability customer needs to build secure, manageable, and application-ready edge AI platforms. With Ai FDO, you can onboard devices securely. With AiSMA or AiNexus, you can choose the management approach that fits your environment. Our OTA service helps keep software and middleware up to date after deployment. With AiOOB and AiOOB management, you can recover systems remotely when normal access is not available. With AiSafeguard, you can protect deployed systems from external device risks. AiUAC and AiUAC Copilot support open automation. AI into Agent adds edge AI insights. And our physical AI capability supports robotics and autonomous machine applications. If any of these areas match your project needs, we would be happy to start with the technical discussion or demo. Thank you very much. We look forward to supporting your edge project. Thank you for joining me today. We hope today's session gives you a clear picture of how this solution can support your project. We look forward to working with you and exploring the next opportunity together. Thank you.